All right, everybody. Uh, Today we're moving on to section 3.3 in our textbook, and we're going to use the square root method, which we have been practicing. We just practiced it yesterday to solve quadratic equations, but these are going to be what we call perfect square trinomials, and I'll explain what those are as we go along. Again, remember what we've been practicing uh, in section 3.1 and 3.2 is the different methods for solving quadratic equations that have an x squared term, linear term, and a constant. Now, we did learn that sometimes, hey, if they don't have this linear term, the bx, we could kind of shortcut the problem with a different method, rather, excuse me, for solving them. The first method we use, though, is you just graph the darn thing. And we look for those x-intercepts, also known as zeros. Where does it cross the x-axis? Zeros. Then if it didn't have that b term, then we could use the square root method. And we also then learned or practiced a little bit of factoring. Now, today what we're going to do is we actually have to combine two of these methods together. Square root method and the factoring method. And all these problems are set up for practice of this type of problem. So let's take a look at, again, we can use this square root method along with the factoring method to solve the problem. As I go through this, what you will see is that, like, you might go, well, how does that work every time? Well, the answer is because these problems are an example. Here's one of the problems, or something very similar to what we had the previous day. Okay, we said, hey, get this perfect square. Perfect square just means something I can square root, and it comes out nice and even. And it equaled 4 in this case, so you could square root this side and square root this, and that eliminates the squared, so the square root undoes the square, and you get plus or minus, and you have to square root the 4 here, which is just 2. And then we could take the 5 over to find out what x is, so we're going to subtract the 5, and you get x equals negative 5 plus or minus 2. Now, in this particular case, we can actually do negative 5 plus 2. That's this part, which would give you negative 3. So there's one of our solutions to this quadratic equation. And then we could also do negative 5 minus 2. That would be this part. 5 minus 2, negative 7. That would be our other solution. Now remember, these solutions, all they are is the x values that make the original equation true. Let's just check one of these. I won't check both, but here's the original equation that was in black up there. X plus 5 squared equals 4. Let's check the negative 3. The smaller number makes it a little bit easier. We'll just see. If I put in negative 3, does it indeed equal a 4? Well, negative 3 plus 5 is 2 squared, and 2 squared is 4, and 4 does indeed equal 4. So 4 equals 4. So we can see the negative 3 makes it true. The negative 7 would also make it true as well. So that's all we're looking for. All right, this square root method, if you have a perfect square on the left-hand side, it makes the problem really short and quick. So let's take a look now at how for it to work. How can you use this square root method then to solve it? It's exactly this original problem. And so your equations today are going to be work. Tomorrow what we will learn is how to get them set up to always work. Today we're just practicing, hey, if it is already set up to work, how does it, how can you solve with it? And then tomorrow we'll learn how to actually get it into this form. So here I have a quadratic equation. You can see I've got an x squared plus 10x, so it has a linear term. A constant term equals 4. today what you're going to have to do is just factor the left-hand side. Once you get the left-hand side factor, you will see. So let's go ahead and factor it. So we got this nice trinomial here. It's in standard form, the x squared, the x term, then the constant. And we talked about how when you want to factor, make a pair of parentheses. The first term, the x squared, has to be a product of these first two terms. So the only way to get an x squared is it's got to be an x, sorry about that, an x and an x. The last term, the 25, is always going to be a product from these last terms in each binomial. So to get a 25, there's only one combination that works. That's 5 and 5. Okay, if you think about the distributing process, x times x is x squared, and you have to do the x times 5, which is 5x, the 5 times x, which is also the 5x. Right here, well, this 5x and this 5x, they add up to give that middle term. So we want them both to be positive in this case, like so. We haven't touched the right-hand side, and you won't need to today, not until we get ready to solve the equation. But what I want you to notice is this right here, these two binomials are identical to each other. X plus 5 times x plus 5. Well, how do you write that? Well, you write that as x plus 5 squared, and that equals 4. And that now set up essentially that all you have to do is practice factoring these perfect square trinomials, and they're called perfect square trinomials because they factor into a perfect square, an x plus 5 quantity squared, which can be square rooted, which means it's a perfect square. So let's look at another example of this case. Here we got a 10 and a 25. So if it was always double, that would be a 10 and a 20. That's not the case. So there's some other pattern that's going on. The pattern I'd like you to notice is this one, because this is going to be useful later on. If I took that 10 in the middle, divided it by 2, I get a 5. And 5 squared is 25. Okay, again, it's going to be set up for you so you can have success right away. All you do is say, all right, I'm going to factor that left-hand side. Okay, again, first term comes from first terms. Last term comes from last terms. And since we're going for perfect squares right now, it's got to be the same number, so only 4 times 4. There's lots of combinations that can give you 16. 1 times 16, 2 times 8, and 4 times 4. But we want that perfect square. And thank goodness it's an 8 in the middle, because that means plus and plus. Because this 4x, the outside, and this 4x, the inside, add up to the 8x in the middle. 4x and 4x add up to 8x, our middle term. And you can see now we've got these perfect binomials that match. So x plus 4 squared equals negative 4. At this point now we're ready for the square root method. So we square root both sides, x plus 4, because we square root something squared. Ooh, square root of negative, but now we have the complex numbers, plus or minus 2i. And we take the 4 over, and we're done. X equals negative 4 plus or minus 2i. Again, we get two answers for this, negative 4 plus 2i and negative 4 minus 2i. Now, I do want you to notice a couple of things. We should start to kind of maybe notice a pattern here to try and recognize these perfect squares. Look at this as an 8, and that's a 16. Now, it is double it, but that's not always like this is an 8 and 16. So if I took this 8 in the center, divided it by 2, that's a 4. And 4 squared is 16. So it's always half of that middle number and then square that answer. And if that pattern exists, then it is this perfect square, and it can be factored as such. That means you can use this square root method on it. It's a really complicated thought, but let's look at it this time. If I was thinking, well, what's half of 20? Well, that's 10. And what is 10 times 10? It's 100. This is a perfect square trinomial. I know that right away. And so I'm just going to write two factors here. I know it's got to be x and x. To get 100, they got to be the same number, so it's got to be a 10 times 10. And they have to add up to a negative 20. That means this has got to be a negative 10. This has got to be a negative 10. So these are both negatives. There we go. We got our perfect square. And now we can use the square root method. X minus 10 equals, got ourselves a plus or minus I root 8. Now we got to factor that 8 down and kind of clean it up. We've talked about this. This is 4 times 2. I can square root the 4. So it's x minus 10 equals plus or minus. I square root the 4, which is 2. And then I got that extra 2 that's hanging on inside. Take the 10 over, just throw it in front. 2I root 2. And we are done. Okay, so it's going to take a couple of different skills now at this point. We've got to use factoring, and then we've got to use the square root method in combination. And of course, we're using complex numbers now, the imaginary number I. So let's take a look at this guy. Let's say we've got x squared minus 16x plus 64 equals 100. Okay, let's just check. And we don't have to do this checking today because they are set up to be perfect squares. But let's just think about that pattern again. If I take that 16 and divide it by 2, I get 8. And 8 times 8, 8 squared, is 64. So this is going to be a perfect square trinomial. But even if you don't check that first, all you can do is you can just say, hey, I'm going to try and factor it. X and x. Well, 64, if I want it to be a perfect square, I'm hoping it's 8 times 8. There's lots of options though. 1 times 64, 2 times 32, 4 times 16. But I want that 8 times 8 because I think it's a perfect square. 16 in the middle means they're both negative. Equals 100. There's my perfect square. That's an x minus 8 quantity squared equals 100. Square root both sides. X minus 8 equals plus or minus 10, and I take the 8 over. Now again, this one I can simplify because I have two real numbers. I got 8 plus 10, 18, or 8 minus 10, negative 2. There's my two solutions. All right, that should give you a great run-up for today's homework. I do want to do problems 1 and 6 on your homework for today so you can see how to do them. So here's problem number 1 on your homework. Problem number 1 is just factor this. X squared minus 8x plus 16. Problem number 6, kind of its partner, is solve this. X squared minus 8x plus 16 equals 25. These are paired together so that you guys aren't overwhelmed. All you have to do is, this part is just factor. This part is use that to solve. So here I go, I'm going to factor this guy. All of these will be perfect squares. So the 16 here, it's always going to be whatever makes it a 16 that is the same number, in this case 4 times 4. If that was an 81, it'd be 9 times 9. If it was a 25, it'd be 5 times 5. But in this case, it's x minus 4, or x minus 4 squared. Then in number 6, the problem across from it, that's the same part of the problem. And so we go, oh, that is x minus 4 quantity squared equals 25. And now we square root both sides. So now we're back into what we did just yesterday. Plus or minus 5, plus or minus 5. So I've added the 4 to both sides, and we get our two answers, 4 plus 5 and 4 minus 5. And those are the two solutions that would make this problem true. If x is 9, you're going to get 25 for a solution, and if x is negative 1, it would also equal 25. So they both make it true.